You did not. I am so sorry. But two things. One, take your homework out so I can come pick it up. Two, in your composition book. Seems kind of easy, but expand your brain a little bit. Think of any different kind of number you possibly can. I'm going to give you 2 minutes while I take roll and then come around and pick up your homework. I did tell you, if you were not here for whatever reason, I did tell you that starting today, all classes will wind up being on YouTube. I've loaded first, second, third, fourth period already. They're already in Google Classroom, and you guys will be there by the end of the day. Maybe seventh period, but we'll see how that goes. All right, so every different kind of number you possibly can think of, think outside the box. What you're looking at. Go, 2 minutes. Want to take attendance real quick? There is no page necessarily this is associated with. And all the calculator notes to date are also on Google Classroom and my website. In case for whatever reason you missed some at some point in time, you can go get them. All right. So, what you got? Sir? One.
2, 3.
That's enough, Justice. Ma'am? 25. Okay. I've got two versions of a whole number. Yes? -9. Got a oh, because it's on freeze. Thank you for telling me. What else? Jonah? One more time. 1 million, is that what you said? Okay. Sir? 1.1. Ma'am?
0.78682.
Okay. Sir? 1/2. Sir? Okay. I'm just going to say 1 Googleplex. It's a big number. Okay. Anything else? Sir? 1 more time? 3 to the power of 2. Okay. All right. If we have 3 to the power of 2, since that's equal to 9, can I do this? Square root of 9. Yeah. that will give me a number. It's represented as one thing, but then when I do the actual operation, I go the other direction. One thing that I am missing, just as a thought, is anything with that symbol on the back of it. Because if I can do fractions, if I can do decimals, then I can also do percents, because they're all kind of tied together as far as that triangle is concerned. Yes, ma'am?
8%.
Okay, I'll throw the 8 in front of it. All right, so 8%. So all these, in some shape, form, or fashion, are related back to rational numbers. Each one of them, somehow, some way, can be written as a fraction at some point in time, as long as the denominator is not equal to 0. Okay, so at this point in the game, you should have at least, I'd say, a B, maybe a B plus understanding of what actually a rational number is, or at least be able to give me an example of it. You may not be able to regurgitate the actual definition, which I'm not asking you to do that, but at least have a fair understanding of what it actually is. Sir?
With how you say many different colors and numbers, could you put like 1 gram? Does that count?
Yeah. The gram part would just be the label. I'm just talking about the actual number. So you could be 1 gram, it could be 1 liter, it could be 5 Googleplex pounds, whatever it may be. You could do that. So that's what I'm kind of hoping you'll be able to do by the time we're done in regards to irrational numbers. Now, I don't ask y'all to do this very often, and I won't ask you to do this very often, but inside your books, on page 59, there is a paragraph. What I'm asking you to do is take the next 2 minutes, just read through that paragraph. If there's anything that you find pointful for you, go ahead and underline, box, circle, highlight, whatever you choose. And I'm going to come around and I'm going to pick up your homework. Name kind of helps me. Names help me. Thank you. I have yet to be able to identify whose handwriting is whose as yet. I don't know that I will at all by the time the year is over.
Mine's just bad.
But I definitely don't know handwriting. Oh, dude. Man. Pushing the boundaries of my ability, my investigative abilities to be able to find that.
Wait,
Okay? Thank you.
wait, what page was it?
5758. Some people turned it in before they left on Friday. Some did not. You? Something to note for any of you? Something you underlined? Something you circled? Anything? You read the whole paragraph, said, yep, I got that. I know what that means. Yeah, no. Okay, that's fine. One thing I want to kind of point out to you, and this may seem kind of nerdy, but math takes a really long time to change. Really long time. In fact, if something were to actually change in math, sometimes it takes a generation to actually do it. I know, that sounds kind of stupid. You roll your eyes like, why would I even care about that? Well, think about this. And I've kind of either read or saw it on a television show or something like that, where y'all are a generation who will never know life without a smartphone. Ever. You think about that in terms of whenever your first memory of an actual phone, you only think of a smartphone. You don't think of a flip phone. For that matter, many of you, although some people still, this still exists for some people, but many of you don't even really know what a landline is. You may know what it is, but there's not one in your house or wherever you live. For that matter, you may not know life without streaming media, streaming video. You have, and this is not a criticism, so please don't take it that way. You can't always relate to a CD. You think in terms of Pandora or iTunes or Spotify or Amazon Music or whatever your streaming service may be. You get the majority of your information and or news from Wikipedia, Twitter, maybe even Instagram or Snapchat. You may or may not go to Facebook at some point in time to look for that kind of stuff, or Reddit. You're literally forming some of your opinions based on somebody else's thought. And there's nothing wrong with that. If you agree, then fantastic. But you kind of go with that. But in math, 7th century was almost 3,000 years ago. And some dude in India thought, for some reason, that this idea of only being rational numbers and the way they can now do it just can't be right. So he literally spent his entire life proving it wrong. And while that may not seem like a worthwhile venture for you, for some people, that makes a lot of sense. Just like now, you have the ability to literally watch somebody when you talk on the phone. Whereas 5 years ago, you couldn't. But a change in math, very small change, changes the way video is streamed through the air, literally, and you can pull it down onto your smartphone to be able to do that. Whether that's Google Hangouts or FaceTime or I think, is it Instagram or Snapchat that actually has that ability too? Both of them do now. In fact, I think I heard there is an update coming from the iOS for iPhone where you can have a group conversation on FaceTime also soon. Which, okay. I don't know that I really want to talk to that many people at a time on one screen about the size of my hand, but if you can, fantastic, whatever. But I know there's also ability to literally talk to somebody and look at them from across the sea now too, as opposed to just picking up the phone and calling. That's also another thing that you guys don't, I just thought about this, that you'll never really have reference for is long distance calling. A long time ago, I know, back in the Stone Ages, you had to dial 1 before you dialed the number and all 10 digits afterwards. And then you got charged more money for making that call. However, with a cell phone, all you need is the area code, the phone number, and it's just part of your calling plan. And you don't have to worry about that. So, on the screen off to the right of the page, there's two different versions of two different numbers. One is the square root of 2. The other one is pi. So I want you to do two things first. One, I want you to open your calculator, turn it on, clear everything out because other people have been messing with it because one is still muscle memory. And I want you to put in the square root of 2. Then hit enter and just see what's on your screen. I don't need you to read it to me. Just do it real quick. Find the square root of 2. Do the square root symbol first. Put the 2 in. Then hit enter. And you'll have something that looks similar, 1.4142 something. Beyond that, the next thing I want you to do is if you look in blue, right underneath the clear button, you're going to see something that looks like a house. That's the pi symbol. I need you to do that too. So second, that little arrow key, caret key, and then hit enter again. And you should get 3.14159.264. Or something along those lines. Got them?
No.
Which one?
The pi.
All right. You need the second button first. Just underneath the clear button is that caret key. I need you to push that one. And that'll give you the symbol for pi, and then just hit enter.
I didn't get the square root of 2.
All right. First you got to do the square root symbol.
I don't know what that is.
It's the blue button and then
It's the X squared key.
Oh.
There you go. There you go.
Mhm.
And 2. And then enter. There you go. Now do pi. Beautiful. Okay. Now, in 15 words or less, I want you to answer A and B. Yes or no, but I need the why. So yes or no, you choose which one you think, but then why. Why, if you say yes, that is the entire value of pi, why? Or yes, or no, that's not the entire value of square root of 2, why? Just tell me why. Why do you think? I don't need a novel. No or yes. And then tell me why. Okay. So not the two of them combined. Separate. So we're gonna do this one. Just that one. And then just this one. Not the two combined. So based on that, this right here. Yes or no? And why you done? Yes, Ian. Quick. And something a little more than yes, because I say so. That's what Coach Wilson said. Ooh, that helps a lot. I'm going to start with pi. How many of you said no? I got one, so we got no's. We got 1, 2, 3, 4, 5, 6, 7, 8. So just 8. 8 of you said no? Okay. 2, 3, 4, 2. Okay. Why no?
Because the number expands.
Maybe a number expands. Oops. Okay. Anything else? No, why?
I said no because I just said it keeps on going.
No, because it keeps on going.
And going, and going, and going, and going.
Got it. The Energizer Bunny. Okay. Anybody else? No for a different reason? Okay. So that means 20 of you said yes. Why? Because why? Sir, why'd you say yes?
Because you ever used 3.14 as a pi before.
Okay, because you only use 3.14 for pi. Okay. Anybody else? Something different? Thanks. Glad you're here. So 1 out of 20 said because 3.14 is pi? No? Okay. How about the square root of 2? How many of you said no? Everybody said yes?
I said no.
You said no. Okay, just say no. So why?
I don't know.
You don't know.
I just said
IDK. Okay? No, but IDK. Sir.
Can't you put another number on the outside?
Can't you put another number on what side?
The outside.
The outside? The outside of what?
Like
The outside of pi or the outside of the square root symbol?
the square root.
Can you put another number inside the principal?
Yeah, like a number at the top. Because then
So a different root. Can do that. Right now we're just concentrating on square roots. We're not going to do cube roots or fourth roots just yet. We're just concentrating on square roots. Okay? I'll take that. No worries. Okay, so in your composition book, a couple things we need to write down. I like IDK. All right, so first, you had this right here. And this is where all the whole numbers existed.
whoever's coming, can you please stop?
Thank you. Whichever one it was. Okay? So we had whole numbers. Now, when you go back and you look at all those different examples that we wrote down as far as just numbers are concerned, that's your 2, 3, 4, 5, 588, 1 Googleplex, whatever it may be. That's all your whole numbers. Okay? Now, that's one layer of the donut. Then we had integers. And as far as your universe was concerned, this is how it's kind of built. And integers, now, I didn't mess you up. I can continue to mess you up, but your teachers kind of messed you up a little bit and said, hey, these are both positive and they're also negative. They didn't mess you up? Good. Okay, so positive and negative, specifically integers. But in addition to that, then we got this new layer called rational. And rational, that's when we threw in fractions. And with that came decimals. And percents. And way out here, where Pluto used to be, it's still there. But where it used to be, we threw in irrational. They are two completely different things. They have irrational numbers have elements of what rational numbers are, but your main goal by the time I'm done with you today and tomorrow is one, be able to just estimate it. About what is it? You're not going to be able to find the actual solution for an irrational number. Your main job is to take what you can find from it and say, yeah, it's about this. Okay. And if you're close enough without being way off, almost like The Price is Right, try to get close enough without going over kind of thing. It's a game show. Maybe one day you can watch it during the summer. Okay? And if that's possible. It may not be. So, but with rational numbers, a couple of things that we've done over the last few days last week. We had repeating decimals. Actually, I'm just going to say repeating numbers. It's not always a decimal, but sometimes it is. It leads into a decimal primarily. Yes, sir? I'm so glad you found your homework. Yeah, I told you, Tuesday. And repeating numbers literally are any number that has a recognizable repeated pattern. Whether that's 3333333 or 14141414, as long as it's recognizable, you know what it is and you can see it because it repeats over and over and over again, then you're good. That's repeated decimals. All right, who did it?
It was me. I'm sorry. I stole
It was all
it.
you? Sorry. You can hide out here for a little bit, but eventually I have to let you go.
I need your car keys.
Nope, sorry. You're going to have to hoof it on foot. And for just as examples for you guys, one thing that we talked about, we had 1/3, which ultimately was 1 divided by 3, and that gave you the 0.3 repeating, just as an example. The next one I kind of backed up with was terminating. And without overselling it way too much, this is a decimal or number that stops. Can be. And the reason why I say both a decimal or a number, because you could say 4 divided by 2. And what is 4 divided by 2? It's just 2. So it doesn't get to the decimal portion of it. It's before it actually hits there, so it could be either a number or a decimal. Okay? So, and this, one example, if we do the decimal part, 1/2, 1 divided by 2.
Mr. Bourne, I found someone's homework on the floor.
Cool.
That sucks for them.
Maybe. Okay, so just 0.5. It stops right there. But here's a definition for irrational. Actually, I'm going to wait for pencils to stop. Sure. Yes. All right. Irrational. And I'll say, Justice brought his dad's calculator up here. And he used it over the weekend to do his homework. And one of the things that I noticed about that particular calculator was it's a construction calculator. Specifically, no, there's nothing wrong with it. There are different calculators that do different jobs. And for the calculator that he has as a contractor or someone who works construction, somehow, some way, it has specific functions inside of it that will mirror real life scenarios and get you as close as possible without having to do a whole lot of extra math. And that's where this comes into play as far as irrational is concerned. So irrational, all right, here we go. I love the fact that sometimes the books give definitions, but sometimes they're more confusing than the actual word. Okay, so this is any number. Actually, I'm going to say any real number.
What do you mean by real? Aren't all numbers real numbers?
Whole real. All this is real.
It's not fake.
It's not fake.
So what's a fake?
There are numbers called imaginary numbers,
What is that?
literally. It would take too long for me to explain to you right now.
It's like that one.
No. Okay, so any real number
That.
Nope. Yeah, see, you messed me up. Oh, it sure does. Thank you. What is this? I'm using a root symbol. So basically, you've been exposed right now to two of them. Pi is one of them, and square root of 2 is the other. The extra piece I'd like to add on here, and I'm going to spend just a moment kind of talking about it, is these are non-perfect squares. So there's an ongoing assignment on my Google Classroom. It's not necessarily for a grade. Really, it's just to stretch your mind a little bit. Where I ask you, what are the perfect squares from 0 to 100? And I'm going to expand that to mean probably to 1,000 at some point in time. And it's not because I'm trying to torture you. It's not because, hey, I think this is really fun and you should do this. It's because in a lot of ways you're going to work with classroom math. If you can at least know the ones from 0 to 100, it makes some of the things you're going to do between now and by the time you graduate just a little easier, because it just becomes kind of second nature. But when I say non-perfect squares, I'm talking about things that aren't this. So 4, 9, 16, 25, 36, 49. Stop right there because I ran out of room on my pad. So these are perfect squares. Yeah, Jonah, go. These are perfect squares. What I mean by that is 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. So the square root of 16 is 4. The square root of 9 is 3. Square root of 25 is what?
4,
5.
5,
The square root of 49 is what?
9,
7.
Close. 7. However, 9 squared is what? 81. So then the square root of 81 is what? 9. So it's a back and forth kind of thing. And what we're going to do next is part of the approximation thing, to try to get you to see about what it is, as opposed to just trying to figure out exactly how to do a square root, because it takes a long time. And there's no point because you have a calculator. But let me show you a little bit by hand before we move on. So I'm going to kind of skip the rest of number 1. I'm going to hit sometime with number 2 just because I'm going to give you the gist of what number 2 is kind of wanting you to know. Again, as Mr. Long and I had, kind of discussed and decided, there's so much that y'all can do with a calculator that sometimes doing it by hand is really counterproductive. So
What is that?
it's just not necessary. I mean, you can do it just for the sake of doing it, but if you have a tool in your hand that kind of helps you get there faster, what's the point? So that's why I mean like counterproductive. So let's go back here. So I've got 4, 9, 16, 25, 36, 49, I'll do one more, 64. Okay? Now, ran through a little bit about perfect squares just in general, but let's take this one up here. It talks about 18. Square root of 18. What in the world? That was weird. Where did it all go? Oh, I hit the second. Okay. So, talk about square root of 18. So, just looking at the actual number, 18. On this number line right here that I kind of drew, it's not really a number line, but it's close. Where would you put 18?
Between 16 and 25.
Okay, so somewhere between these two is 18. Okay? So it talks about square root of 18. So what's the square root of 16?
4.
But what is it? 4. Okay, so square root 16, 4. All right? What's the square root of 25? 5. So, just as a guess, where would the square root of 18 fall?
Between 4 and 5.
6.
Somewhere between 4 and 5. Why would it be 6?
Oh, I didn't mean to say 6.
But you did.
I didn't mean to say
Okay. All right. So, somewhere between 4 and 5. The reasoning behind it being somewhere between 4 and 5 is because 18 literally sits somewhere between 16 and 25. If you wanted to get technical about it, it's 2 away from 16 and it's 7 away from 25. So which is it closer to?
16.
16, okay? So if I had to just kind of guess, again, not using the calculator, not having to do anything mathematically, where would it be closer to? 4 or 5?
4.
Probably closer to 4. So we'll just say square root of 18 is closer to 4. Yay, 18. Okay, so if you were to put these in order, square root of 16, square root of 18, square root of 25, would you put them in that order or something different? That order. In the end, the numbers themselves are still numerical and they're still in a sequence. Trying to figure out exactly what the square root of 18 is always a fun way to spend an afternoon, but you have a calculator. So, find me square root of 18.
8682.
Square root of 18. On your calculator. Find the square root of 18. Give me 4.26 something. I lost the rest of it. Okay? So, is it true? Is our guess that it's closer to 4 than 5?
Yes.
Yeah, it's closer to 4 than 5. So, let me choose another one for just a sec. Let me erase this stuff real quick. So, erase. I need a bigger eraser. Made it smaller to make it more detailed. Now it's too small. Okay? I don't know why that's down there. Okay. What am I doing? I was erasing. Sir? Can you give me 5 minutes? Yeah. Thanks. Appreciate it. All right. How about, let's see. Let's do 33. Where does 33 fall?
Between
25 and
32 and
What number? 33?
What did I do?
Between 5 and 6.
Somewhere right there. So it's somewhere between 5 and 6. Okay? So which is it closest to?
6.
Why?
Because if you run it's 7.
No. Okay, without the calculator. Why? Why is it closer to 6?
It's 33 closer.
Because 33 is a whole lot closer to 36 than it is to 25. From 25, it's 8. From 36, it's 3. So it's closer to 36. So if you had a number line at some point in time, which you're going to, unfortunately, but if you have a number line at some point and you're asked where to put this, you're going to want to put it closer to the number you think it is. Now, if you got the calculator, brilliant, it kind of gets you closer. But if you didn't want to whip out your calculator because it wasn't just jiving with you at that moment in time, that's how you do it. Now, the rest of the stuff, is kind of irrelevant. But what my hope is, in the end game, that's what you ultimately need. All right, so move on down. For me, anyway, give me, if you would please, the approximate. Now, here's what I'm going to say. I want you to estimate, round the answers to the nearest tenth for all of these. This is the symbol for estimation. I want you to estimate to the nearest 10. You can use your calculator because that's what it's for. Square root of 18, 42, and 98.
What was it again?
61.
The nearest 10?
To the nearest 10th. 10th. To the nearest 10th. Ready?
No, I am.
You need help. Sir. You know where the 10th place is? Okay. 10th place is that one right there. So if we're going to round to this right here,
I thought you just stated.
correct? Justice. Hurry. You're going to have to wait for him. All right, square root of 18 is about what? It's about 4.
24.
4 point what?
24.
2, 4. So where's the 10th place? No, the 2. So you look at, as I was talking to Benito, he goes, well, you just leave it. Well, because you look at the hundredths place to see where you're going to push it. Are you going to push it up or push it back? Now, do you think it's acceptable to say it's about 4?
No.
Just asking, do you think it's acceptable to say it's about 4?
Yeah.
Yeah, it's okay to say it's about 4, but that's that key word, about. Not quite. Not exactly 4, but it's close. And it's just a little bit bigger than that. How about the square root of 42? 6.5? 6.4 or what? 6. So if that's the case, this is 6.5 because it rounds to the 10th. Jonah.
My calculator's supposed to say this.
Is it supposed to say what? You tried to take whatever that answer was as your root. See, that's the root you tried to take. That's a little big. What is the square root of 98? 9.9. Now, if I wanted to take a cube root, where is that?
1. Wait, what?
How do I find a cube root of something?
You put it on the calculator.
It is in the calculator, but where is it? You click math. Hang on. What option is it? So which one? The fourth one. All right. Peace out. Love you. Have a great day.